In this video, we cover the implementation of the drawing program by looking at code in representative classes. What you will find is that almost all classes are fairly easy to understand. Although the number of classes is large, the program itself is not a truly intractable piece of code. There are 4 basic packages: model, controller, view, to represent the model, controller, and view of the MVC paradigm, and GUI, which contains all the device dependent code, all the graphical user interface dependent code. So if you are using a new device package, it is this package that you need to work on. You can leave the rest of the code untouched. The packages themselves are divided into sub-packages, and some of them contain Java files, but there could be sub-packages. Like model contains a shape sub-package and model.java. Controller contains states, events, and command packages. And then there is an undo manager here. There is an interface, etc. You can explore the project to see the exact division. The view contains relatively few elements. It just contains an implementation for the logical view and a couple of interfaces. Let's look at the command class. The command class is abstract. It has functionality to undo and redo a single command and execute it. And there is an end method that we added so that when a command is finished, you can call it if you want to do special things. The polygon command captures the essential things related to a polygon. So what it does is it stores a polygon object so that when this command to create a polygon is undone, the corresponding polygon object can be removed from the model. Whenever you issue a polygon command is created. So when a polygon command is created, it takes in a point to have the first vertex of the polygon specified, creates a polygon object, stores it here, adds the point to the polygon, and executes it, basically storing the polygon object in the model, so the polygon would then get displayed. Execute command is to add the shape to the model. Undo would remove the polygon object from the model. Redo will execute it. This is going to be the same, pretty much the same code for all shapes. End is going to add the first vertex as the last vertex of the polygon object so that we can easily render a polygon, and add point adds one more point to the polygon object. So it calls the add point of the polygon class to add the point. The polygon class is one of the subclasses of the shape class, which we saw in the design of the drawing program. There are a number of events. This is an example of an event when we are confirming that this is the last label or that this is the last vertex. We generate this event. This is actually generated on the GUI by pressing the enter key, but that is not of concern here. It is a singleton, as you can see here. And it is. Let's now look at the line drawing state, which gets executed when we are drawing a line. Now, for every command we have, or for every command to draw a shape, we have a separate class. So this state or this class is for drawing a line. We come here when we click the button to draw a line. Now, when we get here, it could be that we just clicked the button to draw a line, or it could be that we have already clicked it a while ago and we are specifying a point. So what we do is we store the current command in the drawing context. Since we are using the state pattern, we have a context, and the context class is called drawing context. It stores always the current command. So if we come here, we first see what command we have in the drawing context. If there is no command, it means we need to create a line command. We are coming here with a point, because we are coming here because of a point has been input. And if we get the command, we create the line command object with the point. And we begin the command in the undo manager so that the command is pushed onto the history stack and we update the view. On the other hand, if there is already a line command, we know that this command that is stored in the drawing context would be a line command. And we set this new point that is represented by this event object as the second point of the line object. And we set the command of the drawing context to null, saying this command is over, and we change the current state to the quiescent state. And we call the end command of undo manager to say that we have finished executing the command. The drawing context implements the controller interface. So whenever something happens on the controller, on the physical graphical user interface, whenever you click a button or when you click a mouse or whatever you do on the interface, an event is generated and the drawing context method appropriate for that event is called. So all the events handling methods are in the controller interface, and there are handle event methods for all possible events. There are many more methods, but we don't have space to show all of those. For example, when you create a line, when you click that button, we come to this method. When you create a label, we come to this method, and so on. There is a method to change the current state. When we start the program, the current state is quiescent state, and we move to that state. And when we want to change the current state, the new state is next state, and we leave the current state and go to the new state. And current state is set to whatever we get as parameter. And these are methods to set and get the commands which we saw in the previous slide. The undo manager has two stacks, the history stack and the redo stack. And this is a singleton. We haven't shown the code for the singleton here. When we begin a new command, we get the command from the corresponding controller state, and we clear the redo stack and push this command onto the history stack. And when we end the command, we just update the view. And the undo operation is like this. We get the command from the command object. If it is undoable, we push it onto the redo stack. Similarly, if the command is to redo, we redo the command. If the command can be redone, we pop it from the redo stack and push it onto the history stack. The model is a fairly simple class that is nothing but a collection. And it is also an observable, as we have seen in the design. So we have the property change support field here. There are methods to add, remove, get shapes, and these are methods for the logical view to add and remove itself. And when something changes within the model, for example, if you remove a shape or add a shape, we call the update view method, which fires a property change on all views registered with this model. Only logical views are registered, and we have limited our implementation to have just one logical view. It is not a huge task to create more logical views in our system. We look at one representative shape class. We chose polygon. A polygon has an array of point objects, and it also stores the number of points in the polygon, number of vertices of the polygon. You can see this keyword transient. I will briefly indicate what this means and why it is there. We will see this in a little more detail later. Transient means this field should not be considered for serialization. So when we serialize a polygon, the array will not be serialized, the number of points will not be serialized. And we chose not to do this, the reason being point 2D is not a serializable class. So if we don't put transient here and we try to serialize a polygon, the code will crash. So it is essential to put transient here for point 2D. And for uniformity, I put transient for number of points as well. But int is serializable. But just for making things a little more consistent, I put transient for this field also. When we add a point, we store that, and we store it again as the next point. The reason being, we will then be able to draw the first pixel correctly. And if there is no more space, we allocate a new array that has twice the capacity and copy the array from points to temp. When we end the polygon, we put the first vertex at the very end. And here is the rendering of a polygon. We go through every vertex and draw the line connecting that vertex to the next one. All right, let's take this again. When we render a polygon, we get a renderer object, and we use the renderer object to draw a line. But what renderer are we using? We are not really concerned in the polygon class. But one possible renderer would use the FX technology, and the FX renderer class is a singleton that implements all the renderer methods for the FX technology. We are not going to go through the details of how these things work. You can look at the JDK documentation. This is not terribly important. So we get a graphics object and invoke methods like stroke line, stroke text, stroke arc, etc. to draw lines, text, arcs of a circle, etc. The logical view class is a singleton. This is the only logical view in the system. It is a property change listener. It is an observer of the model. And it is also an observable because physical views are connected to a logical view. So we have a property change support field. So this class uses property change support as an adaptee. So you can add and remove physical views. When things change in the model, or when the controller feels like it, we will even come to this update method. So if the model changes, the model would end up calling property change, which calls update. Or the controller might say, I need the view to update the display. So it would call the update method. So regardless of how we come here, what we do is we pull each physical view attached to this logical view and call the property change method of the physical view. Or we could simply fire property change that could have been probably easier. But in any case, the physical views would be responsible for rendering everything. But what they do is they call back this method called draw. The physical view would generate a renderer or will get a hold of its corresponding renderer object. They are all singletons, so the physical view gets a hold of that singleton and calls this draw method from its appropriate method. You're calling property change, which will call a method we will see, which calls this draw method. And when this method is called, we are going through all the methods of the model and invoking the render method on each shape, and we pass the renderer method, so renderer object. So we are essentially going to the render method of the individual shape class. So for example, if it is a polygon, we will end up here with the renderer object, and we will be calling the renderer methods, renderer objects draw method. Now, we saw that a logical view can have multiple physical views as observers. Here is an example of one physical view. This implements the physical view for the FX technology. The view has a panel in which drawing will occur, and it sets the title, and that is pretty much it. Some of the other GUI classes A representative one would be a button class for labels. So when you click on the label creation button, we call the handle event method of drawing context for creating labels. So we have this object create label event dot instance passed. So we select the appropriate handle event method of label, sorry, of drawing context. The FX panel is the actual location where drawing really occurs. So this is the one that really becomes the client of the logical view. So when a property change method is called, the draw method is called, which calls the view, the logical views draw method. The FX code for handling keystrokes other than characters is here. So this is purely Java FX code. So you have a handle method to handle key events, and you'll check for certain types of keys and invoke the corresponding handle event methods of drawing context. Then for handling character typings, we have a separate handler. So this gets the correct or the exact character that was typed and creates a character event with that as the parameter to the constructor. So when you look at the event object, we can retrieve the character that was typed. Here we handle mouse clicks. We are not using this click when the control is down at this point, at least in this version. We are going to use it in a different version when we are selecting various shapes, which we are not covering this semester. And this is what we will be using in this version, which is the point input event. When the mouse is clicked, we create a point input event with the X and Y coordinates at which the mouse was clicked. The drawing program itself is an application. So it has the start method to put a drawing panel, button panel, and menu and so on